Okay, the functions f and g have continuous second derivatives, so that means we can take derivatives like madmen and madwomen as needed. And the table above gives the values of the functions and their derivatives at selected values. So for part A, they wish for us to let k of x equal f of g of x and find the equation of the tangent to x at x equals 3. The graph of k, sorry, the tangent to k. So since k of x equals f of g of x, that would mean that k prime of x is equal to f prime of g of x times g prime of x by the chain rule. Okay, so now we need a point. According to the chart, k of 3 would be equal to f of g of 3, which is equal to f of g of 3 is 6, and f of 6 is 4. So we have a point called 3, 4, and then we have a slope, k prime of 3, which is equal to f prime of g of 3 multiplied by g prime of 3, which is f prime of g of 3 is 6, g prime of 3 is 2, and f prime of 6 is 5. 5 times 2 is 10. So the final answer to this problem using that slope and that point would be y minus 4 equals 10 times x minus 3. And that completes part A. Okay, now that we finished part A, let's go see what part B wants us to do. Part B says that h is equal to this particular quotient, and they want h prime of 1. So if h of x equals the quotient, then that means that h prime of x is going to be a quotient rule. Ho d high minus high d ho all over ho ho, f of x squared. So if we want h prime of 1, we're going to need to do f of 1, g prime of 1, minus g of 1, f prime of 1, all over f of 1 squared. Okay, f of 1 is negative 6, g prime of 1 is 8, minus g of 1 is 2, and f prime of 1 is 3, all over f of 1, which remember f of 1 was negative 6, squared. So now we have negative 48 minus 6 over 36, which appears to be, what's negative 48 minus 6 is negative 54 over 36. And then what can we divide by 18? Divide by 18, divide by 18. Looks like a negative 3 over 2 is our final answer. Okay, so last part now, moving on to part C. Part C asks us to evaluate the integral from 1 to 3 of f double prime of 2x. So I'm going to do a quick u substitution here. I'm going to let u equal 2x, so that du equals 2dx, and that means that I can, instead of doing an integral as stated, I'm going to notice that this becomes the same as the integral from 1 to 3 f double prime 2x dx, but I need a 2dx, so I'll put a 2 here and a 1/2 here. This allows me to change the integral into 1/2 integral f double prime of u du, and our bounds are going to change. Let's see, 2 times 1 is 2, and 2 times 3 is 6. So now I have 1/2. The integral of a second derivative is going to be f prime, and that's going to be evaluated from 6 to 2. So I need 1/2 f prime of 6 is equal to 5 minus f prime of 2, which is negative 2. And of course, 5 minus a negative 2 is 7, times a half is 7 halves. And so the final answer to this problem is 7/2.